Welcome everybody to session 4 of Glow Your Own. It's so great to be back and to see so many people. The Oxford Science and Ideas Festival is officially sort of over, but we continue for a few more weeks with Glow Your Own, and then we dovetail into the Oxford Light Festival that's around the 15th of November. And we'll be at Pegasus Theatre doing the Glow Gallery, and we'll have some of these Glow Your Own Arduino bits and bobs there too. So if you find yourself in Oxford on the 15th of November, come to Pegasus and check it out. It's free, and we'll be there from 11 until 4, doing lots of fun things in the dark with light. Today we're going to be adding a little bit of remote control to our circuit, adding a light dependent resistor so that the lamp will go on when it's dark and will go off when it's light, if that's what we decide to do with our coding. So we can choose exactly what we want to do because it's completely customizable. So as usual, we have the team of helpers. We've got Sarah, James, Vicky and Sophie. And so we've all met before, but if we could all do a little wave, it's always nice to see people who's in the team. So as usual, Sarah will be helping out with the tricky bits of coding that's not working. Vicky's going to be doing some making. James is going to be doing some making too, I think. And Sophie's going to be doing the demonstration. So I'm going to pass on to Sophie and we'll get moving. As usual, we'll have the troubleshooting bit at the end of this, which isn't recorded. And if you're watching this on demand, and if you can make it to join in at 6 o'clock on Wednesdays, please do, and we'll give you a helping hand in the last half hour that's not recorded on this YouTube video. Okay, Sophie, over to you.
Thank you, Dane. Hello, everybody. I hope you have all had a wonderful week. So like Dane said, today we are going to be using the world around us. We're going to be using sensors to discover what's happening in the world around us, and we're going to use that to control our circuits, which is always really helpful because I am very lazy. Vicky will show you a little bit later on what we have done with our final circuits today, and we are turning a light on Curiosity, our Mars rover. And when it gets dark, because Mars is a long way away and we don't want to have to press a button every time we want the lights to go on. So it will just go on automatically when it is dark. We're also going to be showing you one of my favorite, most useful things about coding, which is called the serial monitor. And it's how you can get the Arduino to talk back to you and to tell you things about the world around you, which is really useful for debugging. So we're going to start as normal by creating our circuit online. On Tinkercad. So I'm just going to log on. Oh, I'm going to share my screen first. That would be helpful, wouldn't it? So yeah, I'm going to share my screen, and like everyone's, my login code is 2025.glow, and then I'm .001, and everyone else has a different number at the end. We go to the class, and it thinks about it, and we're going to create a brand new circuit. Now the circuit is quite similar to the one that we used for buttons. So that's always nice to be able to build on what we have done before to do that. So I'm going to create a new circuit. So that's over here at the top right, create, and then create circuits. Okay. So we've got a nice new circuit. Dane, don't worry, I'm going to remember name my circuit something sensible. So I'm going to call my circuit Glow Your Own GYO session 4, so that I know what we were doing in this session. Okay.
That's a great name for it.
I thought so.
Very strong.
Yeah. Thank you very much. I'm glad you approve. We joke, but it is actually really important to name your code and your circuits and things that you're going to remember a long time in the past. I might have occasionally named bits of code or named things inside the code slightly silly names because I was getting tired of doing the coding, and then I go back to it a few months later and I have no idea what this is supposed to be doing. And so it is quite an important thing to do.
I'm sure people like James keeps really good notes in a lab book when they're doing experiments and things like that. It's always like keeping a technical diary just to keep track of what we're doing. Yeah,
definitely. James, you always comment your code, right?
Most of the time, yes. It's very it's good practice too, so definitely. So.
It is, yes. I will show you what we mean by comment your code in just a minute. All right, so I'm sure you can guess the first couple of steps to this. We're going to start with our Arduino. Going to pull that out here. And we're going to get our breadboard as well. Now, for some reason, it's really zoomed out. So I'm going to zoom in so that we can see it a bit more easily. It's a bit bigger for us. There we go. Yeah, there we go. All right. Now, the first part of the circuit is just turning a light on. So we've done that bit before, so I will do it quite quickly, but we are recording and it's also on the worksheet, so you can follow along on there as well. So we'll do this circuit and then we'll have a pause to make sure that everyone is up to speed. So we're going to get our LED, our light. I'm going to pop that on the breadboard over here. We're going to connect it to our Arduino, so we can send instructions from our Arduino out to our light saying turn on or turn off. So there we go. Now my Arduino pin number 4, you can see here, is connected to my light. And then you'll remember that we need a resistor, so something to control the electricity that flows through the light. That's going to go to the other little leg of the Arduino and then to the blue line on the breadboard. And remember, I'm going to change the resistance, change the strength of this resistor. I'm going to change it to 220, remembering to change this value here, this units to ohms, not kilo ohms. That's what the little squiggle is, it's an ohm. And then the final wire for this goes from our blue line on the breadboard down to the ground on my Arduino, the one that says GND. And because it's going to the ground, I'm going to change my wire to an orange color. And I'm going to make it look a little bit neater because I like it when things are neat. Okay, so that is a circuit that we have done we've done, I think, in every session so far. So you're all really, really good at that. I know that you're all completely good at that part of it. So give me a thumbs up if you're ready to do the photoresistor. That's what we're going to call, that's our new component that we're going to add in.
A couple of thumbs up, but maybe just a second.
Yeah, we'll give it everything a minute.
Oh, there we go. We've got some thumbs up and some bread.
Very appropriate. Do like the bread. Fantastic. So yes, we've got that there. Now we are going to have a new component that we haven't used before, which is called a photoresistor. So if you scroll down a bit on this component on the right-hand side, you will find it. It's a circle with a kind of squiggly line in it and then 2 little legs coming off from it. And if, so I'm going to click on that, but if you'll remember right at the beginning, we can switch the view for this photo, for all of our components to a detailed one so that it will tell us a little bit about what that component is. So it's always really cool to double check that. So this is called a photoresistor, and it's a sensor whose resistance changes based on the amount of light it senses. So this is a really clever bit of kit. It is a little sensor and it will it will change how strong it is depending on how much light it's seeing. And it will send that information back to the Arduino. So the Arduino will be able to say, oh, it's really bright, or actually it's really dark. Okay, so really, really useful little bit of kit. We use sensors like this all the time at the lab, actually. So I'm going to pull this photoresistor out over here. and I'm going to put it on my breadboard. Fantastic. Okay, so everyone got that? Now, just like the button that we used last week, the photoresistor actually needs to have some power as well. So we're going to connect it to the power pin on the Arduino, which you'll remember was down here at the bottom. If you hover over it on Tinkercad, it says 5V. And so what we're going to do is we're going to connect this 5V to the breadboard, to the red line on the breadboard, just like we did last week with the button. And I'm going to change my wire to a red wire because it's powerful. Okay, and then I'm going to go from the red line on my breadboard, so connected to the 5V, 5 volts, and I'm going to go to the leg of my photoresistor. There. So you can see that the photoresistor is now connected through this red wire, through the breadboard, through the red wire, through the breadboard again, and then all the way down through this red wire to the Arduino, to the 5V one on the Arduino. Okay, everybody got that? Give me a thumbs up if you do. Brilliant. We've got some people already. I'm just going to make it a bit shorter, a bit tidier. We've got some people that have done that. Great job, everybody. That's really good. And then we just like the button, we're going to have a resistor in there that's just going to control control the amount of electricity that flows through there. So I've clicked back to resistor, and that's going to go like this. So it goes from the other leg of the photoresistor to the blue line on the breadboard. Now I'm just going to zoom into the breadboard a little bit, just so that you can see that really clearly, like that. So it goes to this blue line, which is already connected to ground, to GND on the Arduino. And it also goes to the power. All right, we've got one more wire, and it's the most important wire for this part of the circuit, actually, because it's the wire that's going to send the information back to the Arduino that's going to tell us how light it is over in our circuit. Okay, so I'll zoom back out because actually we need to use a different part of a different pin of the Arduino that we haven't used before, which is always exciting. Now, if you'll remember, when we put the button in last week, we connected it to one of these pins up here. And these are called digital pins, and that means they're either on or they're off. Okay, so they can have a value of 0 or 1, and they can't have anything in between. And that's fine when it's a button, because the button is either pushed or it's not. But with light, we don't actually want it to be, the light isn't either on or off, is it? Sometimes it's really, really bright. Sometimes it's quite bright. Sometimes it's getting a bit darker. Sometimes it's pitch black. And we want to be able to tell all of those differences. We don't just want to say, is it on or is it off? And so instead of the pins up here at the top, we are going to use the pins down here. Now you can see that they are labeled A0, A1, A2, A3 down here, and they're called analog in. And that's the word that we use for values that can be lots of different values, not just 0 or 1, but they go from 0 to 250 or 500 or whatever they go to. Okay, so we're going to connect our photoresistor to pin A0. So I'm going to go from pin A0 here. I'm going to draw another wire that's going to go all the way around the Arduino like this. And then it's going to connect to the breadboard here so that it is next, it's connected to the photoresistor. And I'm just going to make that a yellow wire because I'm sending information into my Arduino. So I'll zoom right into the breadboard so you can see exactly where everything goes here. But remember, it's also on the worksheet, so you can look at that. You can also pop a question in the chat if you're not quite sure where something goes. And we've also got the lovely
recording in the future.
Thank you. Sorry, words are really hard, aren't you? I did tell you earlier that it's dark and therefore that means it's nap time. So yeah, so you can always pause the recording. But we now have a wonderful complete circuit, if we've done it right. So give me a thumbs up or an emoji if your circuit is ready and you can do the coding part. Be ready for the coding bits. Brilliant. I can see some thumbs up and some bread. I'll give you just another minute or two. Remember, this is being recorded, so you can always watch us on that, and you can always pause us on that and ask us questions in the chat, and watch the and stick around for the troubleshooting session. Sorry, I was trying to move Zoom because you're over the bit that I need to click next time, and apparently I couldn't do two things at once there. All right, so everyone ready for some coding? Great. This is always my favorite bit, you can probably tell. All right, so here we're going to do some coding. So you click on the button that says code, and then we are going to, as always, delete the code that Tinkercad helpfully, I'm sure it's trying to be helpful, suggests that we do. So I'm going to throw that into the bin and throw that away. And we are going to get our coding sorted. So this code is very similar to the code that we used last week, because what we want to do is we want to ask the Arduino a question. We want to say, Arduino, is it dark? And if it is dark, then we want the Arduino to turn our light on. And if it's not dark, we want the Arduino to keep the light turned off and save electricity, save power. Okay, and we want that to happen forever. So the first command that we're going to do, the first block, is going to be our forever block here. So that's up here in control. And then we're going to use the same really, really useful block or really useful command that we used last week, this one, the if then else button. And that is used whenever we want to ask the computer a question. So we're going to say, okay, Arduino, if the light is above 200, be dark. Don't turn the light, don't turn my LED on. But if the light is below a value, then turn my LED on. Okay, so if it's dark, turn it on. If it's not dark, keep it off. All right, so let's do that output bit first. So we're going to say, if it's dark, turn my light on. So we're going to get to this output here, and we're going to set our LED to high. So you'll see my LED is connected to pin 4 here. So I just have to change that to pin 4. And so that's what we're going to say. This in this little triangle thing, no, hexagon thing, we're going to say if it's dark. And if it's not dark, that means it's light, which means our light, our LED. Oh no, I just moved everything and now my beautiful circuit is not.
I did that just before too, and it really freaked me out.
Yeah, that happens sometimes. Sorry, everybody. So
you can easily fix it though, that's the nice thing.
Very easily fixed. Yes. So where were we? So if it's dark, then we're going to turn the LED connected to pin 4 on. And if it's light, we're going to turn the LED connected to pin 4. So I've changed that number off. So I'm going to set that to low. Okay. All right. Now we just have to do this little bit here. And then we've got one other secret bit that we're going to show you before we simulate it. Okay, so everyone ready for the last bits of code? Or should we pause for a second? How are we doing? I can see there are some things in the chat. Everything okay? Dane and Sarah? Fab. Brilliant. All right then. Okay, so we have to ask the question now. We need to say, Arduino, is it dark? But the Arduino isn't quite clever enough for us to just say, Arduino, is it dark? We have to give it a bit more help to understand what we're doing. So we're going to use some maths, which is the green one that the American Tinkercad calls math. And we need this little hexagon one that compares two different numbers. Okay, so I'm going to pull that out here and click it into my into the question. So this is the question that we're going to ask. And we want to ask if the value of this resistor, so the value of our sensor, is that above or below a certain value. So it's an input. So we're going to click here on inputs. And last week we used this, but we said read digital pin. So that was one of the pins up here. This time we want the one below that says read analog pin, because like I said, we are using these analog functions here at the bottom. So I'm going to pull this over here and say if that value is, I'm going to compare that value to a different thing. And now let's just check that the number in here is right, the pin is right. I could change it to any of these, but yeah, I have connected mine to pin A0 and I'm reading in pin A0, so that is right for me. Great. Now we need to put a value in here that means if it's dark, it will turn on. Now, this value we're going to set to, let's set it to 400 to start with. But I've just told you it's 400, and that's because I've done this before. But you have no way of knowing what that value is just off the top of your head. But the Arduino is really clever and it can talk to the computer and tell us what the values are. So this is my favorite command, I think, in the whole of Tinkercad, because it's really, really cool. So if you go to output, I'm going to show you the most useful command here. So we've already used some of these, setting the pins to different values. But if you go down a bit, there's one that says print to serial monitor. And that just means the computer. It means send some information to the computer. What we're going to do is we're going to put that here inside our forever loop, but outside the question that we're asking, outside the if. Okay? And that prints to the computer. At the moment, it prints something. Oh, sorry. It will just print hello world, which is a very, very common thing that programmers do. James and Sarah, I'm sure, have written lots and lots of hello world programs in lots and lots of different languages. It's often the first thing we do just to make sure that we can get the computer to talk back to us. We say hello world, but we don't want it to say hello world. We want it to tell us what value our resistor, our sensor, is telling us. And remember, that was the input, read analog pin there. So what I'm asking the computer to do is to read this thing, read what the value of the sensor is telling us, and then to print it to the screen. Okay, and that will tell us the kind of different values that our sensor is sensing. And that means we can pick, oh yes, it is bright. So we'll pick this. We can choose a good value for this number here. Okay. All right. This is also really useful when you're bug fixing. We use this kind of thing to fix our bugs all the time because it tells us where we get to in our code before everything goes wrong. So that's really helpful. All right, so are you all ready to start simulation? Give me a thumbs up or some kind of emoji, but I can pause for a little bit because that's got some good new bits of coding. We do have time, so we won't rush through this bit because this is the coolest bit. Okay, I've got some good thumbs up. Thank you very much, everybody. remember, if you are having any difficulties, pop any questions in the chat. Sarah and James and Dane and Vicky, they were all there to help you. And we are recording it, so you can always pause us and watch back and follow along with the worksheets as well as the troubleshooting session at the end of today. Okay, all right, so I'm going to start my simulation, which remember is this button here. So I'm starting the simulation, thinking about it. Right, now, if you click on the sensor here, you'll see this little sliding scale comes up, and this is dark, and this has a little black circle, and this has a little sun picture. So if I slide the, sorry, I'm just going to hide my code so that you can actually see the circuit. So you'll see that it's dark here, and my little light has turned on. But if I slide my sensor up here, if I make it brighter, my light turns off. So hooray, that is working. Have you got lights that turn on and off depending on where your sensor is? Give us a thumbs up or say it's working or not. Now it's on, and now it's, so about here, that's where it changes for me. And that might, which is okay, but I might want it to actually change when it's here instead, when it's right in the middle. So I could just do some trial and error because, hang on, there we go. I could just do some trial and error, and I could change this value and say, well, 400, if I change it at 400, then the light turns on about here. So maybe I should just change this to 500 and that will change in the middle. But because we've put this clever bit in here, we don't need to do that because we can use our serial monitor, which is really marvelous and which is hidden from me by the Zoom taskbar. I was just panicking because I'd lost it. Down here at the bottom, can you see where my mouse is? There is a little button that's sort of at the bottom of the code section on the left that says serial monitor. If you click that, it will show a value, and that is the value that the sensor is sending back to the Arduino. So if you keep an eye on this here, as I slide it, you'll see that as I slide it up here, the value is getting higher and higher and higher and higher and higher. So if I want it to turn my light on, only when it gets to be about this dark, right here in the middle, I can see that that says 559. So if I change this value here to 550, say, yeah, so I've changed that there, and then I start my simulation again, just thinking about it, and now it's right down here in the dark, 6, my light is on, excellent. I turn it up, oh, it's getting brighter, but my light is still on, my light is still on, and right here in the middle, where I wanted it to change, my light goes off at 559. So you can change, you don't have to just pick lots of random numbers and put them in. You can do that, but it takes a long time. And programmers, people who do lots of coding tend to be really lazy, and we tend to like the easiest option for ourselves. So you can have a look at that, and that will tell us what value to put in here. So how is it going, everybody? Have you got lights that turn on and off when it's light or dark in Tinkercad? And can you control it using by changing this value? Give me a thumbs up if you're doing it, if you've got that circuit working. Brilliant, I can see some thumbs up already. Great job, everyone. I have thrown quite a lot of new things at you in the last half hour, so I'm really impressed that you're keeping up thank you very much for all of your perseverance, which is the most important thing that you can have when you're doing coding. Patience and perseverance. Those are the things. Sorry, I'm distracted because the real Dane has just vanished. Vanished into pink. Brilliant. All right. So well done, everyone. Don't worry if it's not quite working. You can pop something in the chat, and then Sarah and James and everyone will be able to help you with your Tinkercad. Remember, we can see your Tinkercad, so we can help you really easily with that bit. But what I'm going to do in the last 20 minutes or so of this session is I'm going to make the circuit in real life and send it to my physical Arduino, my real Arduino, so I can turn my light on and off with that. I can see some brilliant people who have got coding. Brill. Okay, all right, so I'm just going to stop my share for a second now that we've got that. But if you want to have a look at the code or the circuit, a very similar circuit is in the worksheet, a more complicated one, so you can just ignore bits of it. We are going to make our lovely circuit. Now, if you have kept your circuit from last time, then you'll be super quick because it's basically mostly the same. Now I'm going to use my LED and I'm going to pop that into my breadboard, just like always. I'm going to try and pop it into my breadboard. It's being a bit fiddly today. There we go. And then I'm going to connect it to pin 4. So here we go. Pin number 4 to my light. I'm going to get my resistor. And sorry, I've just got to untwist my resistor. And I'm going to connect that from my LED. Yeah, sorry, my hand was totally in the way, so you didn't see that. But this is the bit that you've all done before. So you're all pros at this part. So that goes like that, you see? And then finally, I'm going to connect from the ground to my, from the Arduino to the ground. And now I've just realized, very unhelpfully, there is a little bit of wire that is stuck in my ground pin in the Arduino, which is not very helpful at all. It's okay though, because on the other side of the Arduino, there are some more GND ones. So I'm just going to connect it over there, but you don't have to do that all the way over there. It's just because I've got a little bit of wire stuck in my Arduino because I was clearly too impatient one day trying to pull it out. Okay, so that's the first circuit that we are all really, you've all done before. Now, this is my photoresistor. Now, can you see if I pop it on my palm like this? You can see it's got really long legs and a little circle on the back, back. And if you look closely at the little circle, you'll see that printed on it, there are some wiggly lines, just like in the diagram, in the picture on Tinkercad. So it's really good like that. Okay. So if you still have your circuit from last week, what you can do instead is you can take your button off and move and put a photoresistor in its place. One of the nice things about breadboards, though, is that it's really easy to change your circuits backwards and forwards, like that. All right. So I'm going to add in my photoresistor, my sensor, over here. Now, because it's got quite long legs, it can be a bit tricky to get it in. Well, it can if you're me anyway. I'm not very good at things with my hands. So that goes like that. And then I'm going to put my resistor in, just like on Tinkercad. And that goes. I'm just double checking my circuits because it always makes sense to do that. My picture on Tinkercad. That goes from my LED all the way over here to the blue line on my breadboard, like that. And then we need to connect it to power. Remember now, these wires are the ones that people often forget when they're making their real circuits. So these ones are really important. I mean, they're all very important, but these are the ones that people often forget. So we need 2 red wires, remember. One of them is going to go from one of the legs of my sensor here to my red line on my breadboard over here. And then the other one is going to go from the red line all the way over here to the one that says 5V on my Arduino, like that. And we've just got one more wire and we're done. Now I know that I have done that quite quickly, but remember you can always pause the video and watch back and make sure that you're getting each step as we do it. The important thing to remember with the circuit is if your Tinkercad circuit's working, it should look exactly like the circuit on Tinkercad. All of the wires should go from the same place to the same time. Right, so one more wire to go, and that is this one. So I'm going to go from my, oh, sorry, I moved my thing. I'm going to go from the photoresistor, the leg with the other resistor on it, here. And I'm going to go all the way over here to pin A0. Now you can see that I've got lots of different wires here. And that is when the color coding actually comes in quite handy, because it makes it easier for me to see which bit is which. It does make a lot of difference, really. And the more complicated a circuit gets, the more important that is, the more helpful it is to have this color coding and to see at a glance what different parts of your circuit are supposed to be doing. Okay. Great job, everybody. Just going to move that a little bit here. 8-year-old Dane always teases me because instead of having a proper thing to hold my phone so that you can see it, it's just piled on a bunch of DVDs. Works.
It does work.
So, yeah, it works. So we're fine. We're all good. Okay, so how's it going, everybody? I think what I'll do is I'll give it a minute and then I'll turn my screen share back on and we will go to the Duino app and transfer it, because I really want to show you how the serial monitor works in the Duino app as well. Okay, because you can do that just like you did in Tinkercad. It has a serial monitor, so we can get the information from our real life circuit back into the computer. And that is really exciting for me, because it means that we can learn about the world around us and then we can use that knowledge to do all kinds of different things. And that's really helpful because it keeps us safe, and it makes us save energy and all kinds of other good stuff. So it's really, really fun thing that we can do that with our little circuits as well. Right. Okay, so I am going to switch to my screen share now. Remember that don't worry if you haven't quite made your circuit, or if it's not quite working on Tinkercad, we've got the troubleshooting session that is after this, and I know that that the others are having a look at your code right now, so that they can give you some hints and tips as well. But we'll head over to Duino now so that we can record that part, and then we've got the troubleshooting at the end. Okay. All right. So let me just share my screen. Yep. Here we go. That's the right thing. Yes, here we go. So we've got our, I've got my lovely circuit working here in Tinkercad. I'm going to stop the simulation, and then I'm just going to hide the serial monitor so that we can look at things a bit bigger. You can just click that button there and that will hide it away. Now, you'll remember that the first thing we need to do when we're going to the Duino app to send the information to our real Arduino is to change this here, change blocks to blocks plus text, so that Tinkercad will translate our blocks into this other language, the C++ language. Let's copy all of this. So I'm going to highlight it and then do Control-C, or you can right-click and do copy, like that. And then I'm going to move over here, open a new tab, and do Duino.app. If someone could pop the link to Duino in the chat, that would be fantastic. All right, so I do tick this button and it says that things have changed, but it doesn't matter. Every time I do it, it tells me things have changed. All right, so we're here in our Duino app, and then you'll remember that we have to start by going up here in the top left to press code, because that's what we want to do. And then we're going to create a new project. Create new project. I'm going to call mine GYO session 4. And here we go. Here is our code now. And again, just like Tinkercad, it wants to be helpful and gives us some code, but we don't want it. So I'm going to highlight it all and delete it. And then I'm going to paste my new code that I've written into it here. So I'm going to do Control and V. And that is my code. And remember, one of the most common things that goes wrong in this is that we don't quite copy every single bit of code over from Tinkercad. So it's really fussy. You have to have every bracket, every single character makes an important thing, does an important thing. All right, now I'm just going to connect up my Arduino. There we go. There, you might have heard the computer going ding ding because it found it. Here you go. Sorry, I've only got a small USB lead today, and so it has to be really close to my computer to work. All right, so we've got our code in there. Next step is to select the device. So we click on select device here down at the bottom on the right. Oh, and it's called it something different today. You will see that it called it random thing. So I'm going to hope that it is this thing that says CDC abstract control model. Let's try that, shall we? So click that one. Sometimes it says USB serial USB port. Sometimes it says Arduino. So I'm going to connect that. Now you can see it has connected because it says serial selected down here. And then what I'm going to do is I'm going to send my code to my real Arduino. Now, cross your fingers, because I've never seen it called that, so maybe it's happy about seeing it. Oh, 100% error. How dreadful. Rats. Yeah, you see, it happens all the time to me as well. So what I'm going to do is I'm going to close Duino. I'm going to close Tinkercad. I'm going to stop my share and close Tinkercad. There we go. And I'm going to open, I'm going to plug it into a different port. So these are just the things that you can try when it says 100% error. Plugged it into a different port. You might have heard it go ding, 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 ding. And then I'm going to open a new one like this. Share my screen again. So sorry, everyone. But maybe it's reassuring that it happens to us as well. There you go. So I've got my new thing in here. Duino.app. Oh, too many P's. All right, got it. Code, create a new project. During session 4, attempt number 2. And let's see if it remembers. There we go. It did remember my code. So I've copied that in. It's called USB serial device now, so maybe it'll be happier. Connect. All right, now cross all of your fingers and toes because I really do want to show you the serial monitor before we finish. Let's see. Compiling, uploading. Yay! Fantastic. All right. Let's see. There we go. All right. So now I don't know if you can still see Arduino Cam. But I'm just going to stop sharing for a second so that you can see Arduino Cam here. And if I put my finger over my sensor to make it dark, then my light is on. And if I take my finger away, because it's nice and light, and so the light goes off. Hooray! There we go. All right, now I'm going to head back to Duino for the last few minutes and show you the really cool serial monitor. Now, am I showing the right thing? Yes, here we go. So you can see that here along the top, once you've got to 100% done, here at the top on the left, there's a thing that says program, and that gives you information about what it's sent to the Arduino. But then there is this button that says monitor. Okay, and it says monitor and it doesn't give you any information. And that's because the Arduino is checking what the value of the light is, checking how bright it is at a different rate than the computer likes to show. So down here at the bottom right, you'll see this thing that says, gosh, 115,200 baud, or B-A-U-D. Does anyone remember what B-A-U-D stands for?
Nope. Let me Google that one for you. Here we go.
We're going to find out. I can never remember. I should have looked it up before. But if you click on that and change it to a different value to 9600 BAUD, then you'll see numbers showing up here on my serial monitor. And if I pop my finger over it, you'll see that that number has changed to 400 and something. And if I take my finger away, it goes back up to 700. So 400 and 700. So you can see the serial monitor, so that can tell you the information. And we use things like this all the time. So we have been monitoring the weather at our lab, at Vicky and Mai's lab and James's lab, for longer than I have been alive, I think. So for a really, really long time, because I'm old. And we've got all of that data, and it's all been stored on computers. And so that's been able to, we can use that to tell the weather, to tell things about climate and climate change, and to store all of that really interesting, useful data. As scientists, we love data. We like to store lots and lots of it. And so being able to tell what your computer is telling you, what your sensors are telling you, is really useful when you're trying to fix a problem in your code, but it's also really useful when you're trying to understand your experiments or just the world around you. Fantastic, everyone. I know that we did do that quite quickly, so you're all brilliant for keeping up and for persevering. I'm going to hand over to Dane, but remember we do have the recording, so you can watch back, pause us, and so you can do everything step by step, and we will start the troubleshooting in just a few minutes. All right, well done, everyone. You're brilliant. See you soon.
Really well done. Yeah, thanks so much, Sophie. That's super cool to be able to control our circuit remotely. I've got another quick little thing that I want to just show. So I've got my own Arduino cam that I might see if I can switch this on. There we go. So I've got my own, this is my little kit here. So I've got my Arduino here working. Let's move that around so you can see it. So hopefully you can see a little bit of action going on. It's quite bright. So you can see my lights. You can see my lights flashing on and off. But I've taken, look what I've done. I've unplugged my Arduino from my computer and I've plugged it into a battery. So I'm just going to unplug my battery, and you can see that this is what's powering my Arduino. And just to prove to you, it's the Arduino that's doing all the thinking, and it's not the computer that's doing any kind of control. And I've set it so that if it becomes really bright, I can, let's see if I can, this is one of these tricky things where you have to have lots of hands, and I only have two. So if I make my environment really bright by holding it up to my desk light here, it's so bright that my lights go off. So I'll move it out of the way of the bright light. But this is all just being powered by a battery, or you can plug it into something like a mobile phone charge or anything where your USB can seek power. And so your whole little thing is now completely mobile and occasionally working. Look at that. So you can put this little device wherever you want it to go and demonstrate that it's not powered by the computer that you're developing your Tinkercad with and you're coding with. Oops, knocking that around. So please do have a play with different setups at home. You can change the lightness, the intensity of the light. That means you can, if it's a different level of brightness in your room, or you can have it sort of as a switch. So I've got sort of an optical switch here that goes off and on. And you can obviously change the different sequences of your lights, and you can introduce your button if you want to. So there's loads of things you can now do. So a couple of weeks ago, you might have not known what a breadboard was, an Arduino was, or what these resistor things were. And now you can do so much with that. So I'm really happy that everyone's been able to get involved and do some coding and making.
Do you want to see the
Mars?
Mars?
Of course, no, gosh, yes, really cool thing. I completely forgot. So we've been building, of course, we've been building our Martian circuit. So
we've got the Mars rover's got its headlights ready to come on when the lights get dark.
Yay!
So if I turn my light off, let's see, does it do it automatically?
It's so good. It's so good.
Oh,
so it needs to see what it's doing in the dark.
And so next week, we're going to give you some tips on how to make things like your Martian landscape, or the egg box thing that I demonstrated in the very first session, and a couple of other different makes. So thanks so much, Vicky, for building this brilliant Martian Curiosity rover landscape. So do come back next week and find out how to turn your circuits into some crafty and creative makes. But I would suggest, if you are able to raise the recycling box, is find yourself things like egg box cartons, maybe some clean milk bottles, or any other bits of packaging that is either shiny or see-through or transparent. Other bits of cardboard, so kind of boxes that might come in the post, or other bits of things you can cut up. Obviously ask permission and get some help if you need to cut things up from a grown-up. And if you're grown up, you can just make your own decision, because I know some grown-ups are doing coding as well, which is brilliant. That's it, so great. Well done everyone, and it's goodbye from us, and we'll see you next time. Bye now.